Hello students. So let us go through one more word problem. This time the word problem is based on the four wheel and a rear wheel, right? The approach towards solving this sum forming the equation is quite similar to what we have done in speed, distance and time. If you remember, there are three unknowns. You assume one, second one is given, and whatever remains we need to use the formula for it. So that approach is quite similar to that. But before we start with the sums, it is important that we actually go through the concept, the formula which is related to the sum. So what exactly is the formula? Let's try to understand that. Now, as I said, the sum is about a wheel, the four wheel and a rear wheel. Four wheel is the front wheel and rear wheel is the wheel behind, right? So let's go through a wheel, and a concept related to wheel. Now, see, this is a wheel in front of you, and we can say this is the circumference of the wheel, right? Now, when we say that wheel has done one revolution, right? Now, one revolution is equal to one circumference, right? So, when we say that wheel has revolved once, that is, it has covered its one circumference, first circumference it has covered, right? So, one thing is clear, that distance covered by the wheel in one revolution is equal to 1 into circumference. Once they have covered the entire circumference, that's one revolution, right? Similarly, if there is one more revolution, there is one more circumference that the wheel is covering. In other words, the distance covered by the wheel in two revolutions is equal to 2 into circumference, right? So, distance covered by wheel in one revolution is actually one circumference, one full revolution is one full circumference, and two revolutions is two full circumferences, right? So, can we say distance covered by the wheel in n number of revolutions is equal to the number of revolutions into the circumference, right? So, we come to a conclusion that the distance covered by the wheel is equal to number of revolutions, that is n, into the circumference, okay? Now, because the distance covered is equal to number of revolutions is equal to circumference, can we come to a conclusion that number of revolutions is equal to distance upon circumference? Now, this is a formula that we will be using in this sum. Like distance is equal to speed into time, or time is equal to distance upon speed. Similarly, in this sum, the approach will be using this formula. Number of revolutions is equal to distance covered upon circumference, right? Now, one more important thing that we need to know in this sum, one is the formula, that this is the formula that we will be using, that number of revolutions is equal to distance upon circumference, right? The second important thing that we should know in this sum is something which we already know. Now, we know that the circumference is basically pi d, pi into diameter. So, if the diameter of the wheel increases, definitely the circumference also increases. As you all can see, the diameter increased, so definitely the circumference also increased, because circumference is equal to pi into diameter. So, circumference is definitely directly proportional to the diameter. In other words, whatever happens to the diameter, the same thing happens to the circumference. Diameter increases, circumference also increases. Diameter decreases, circumference also decreases. Circumference and diameter are directly proportional to each other, right? Also, always remember this, if diameter increases by half, then circumference also increases by the same quantity, that is by half. Always remember this, because we all know, as I said, circumference is equal to pi into diameter. Here pi is a constant, the value of pi does not change. So, the value of diameter changes, say if it increases by half, circumference will also increase by half only. Always remember this. If diameter decreases by 1/3, circumference also decreases by 1/3. Always remember this. So, if in the question it is given that the diameter increases by half, you need to assume that because the diameter is increasing by half, even the circumference will increase by half. Always remember this concept, right? And one more important calculation that we will be using in this sum. So, just a quick concept of this calculation, just a quick demonstration. The calculation is, if the question is, if the circumference is x, say the original circumference of a wheel is x meters, and it is given that it increases by 1/4, okay. So, the original circumference is x, and it is given in the sum that the circumference increases by 1/4. How will you find the new circumference is the question. So, this is how we find the new circumference. Original circumference plus increase in the circumference will give us the new circumference. So what is the original circumference in the example? X, right? So new circumference will be equal to x, that is the original circumference, plus, because it increases 1/4 of the original. When you say one increases by 1/4 of what? 1/4 of the original circumference, that is x. So it will be x plus 1/4 of x. So this is how you need to find the new circumference. If it increases by 1/5, then x plus 1 upon 5x, 1/5 of x, right? If it increases by 1/10, x plus 1 upon 10x. So this is how you need to find the new circumference. Now how do we simplify this? We take the LCM, 4 and x gets multiplied, you get 4x plus 1x upon 4, that's 5x upon 4. So if the original circumference is x and it increases by 1/4, then the new circumference will be 5x upon 4. I hope you all understood how did we do this. So these are the three things as far as this sum is concerned. The formula that we will be using is number of revolutions is equal to distance upon circumference. So you can make a note of this. Second is, always remember, whatever happens to the diameter, the same thing happens to the circumference. If the diameter increases by half, the circumference also increases by half. Remember this concept. And third, from the calculations perspective, if the original circumference is x and we say that the circumference increases by 1/4 of the present circumference, then the new circumference will be x plus 1/4 of x, that's 5x upon 4. If you are clear with this, then the approach will be similar to the speed, distance, time related sum. So this sum will be very, very easy, right? So let's do that. The sum looks long, but it is not, a very simple sum. The forewheel of a carriage makes 6 revolutions more than the rear wheel in going 120 meters. If the diameter of the forewheel is increased by 1/4 of its present diameter increases, the circumference will also increase. And the diameter of the rear wheel is increased by 1/5 of its present diameter, and you know how to find the new circumference, right? Then the forewheel makes 4 revolutions more than the rear wheel in going the same distance. Find the circumference of each wheel of the carriage. Initially, as we always follow, don't try to understand anything initially, just read the last statement, and the last statement says find the circumference of each wheel of the carriage. So find the circumference of the forewheel and find the circumference of the rear wheel, so that the circumference of forewheel be x meters, don't forget to write the units, and let the circumference of rear wheel be y meters, don't forget to write the units, right? So out of the distance, number of revolutions and circumference, we have assumed the circumference. So what remains now is the number of revolutions and the distance. Let's see what to do with that. It's given that the forewheel of a carriage makes 6 revolutions more than the rear wheel in going 120 meters. 120 meters, meaning this is the distance covered by the forewheel as well as the rear wheel, right? So let's learn this entire sum in a tabular form. It would be easy. Table should not be the part of your presentation, but it is important from the understanding point of view. So let's do that. Circumference, distance and number of revolutions, and this is the formula that we'll be using. Number of revolutions is equal to distance upon circumference. We just need to fill in the blanks now. The circumference of forewheel is x meters, we have assumed because it is asked. Circumference of rear wheel is y meters, we have assumed. It is given that the distance covered by both the forewheel as well as the rear wheel is 120 meters. So circumference is done, distance is done, what remains is number of revolutions, and we all know number of revolutions is equal to distance upon circumference. We know the distance, we know the circumference, let's divide and find the number of revolutions. So what is the number of revolutions which is covered by forewheel? It is 120 upon x, distance upon circumference. What is the number of revolutions covered by rear wheel? It is 120 upon y, that is 120 is the distance, y is the circumference. We know the number of revolutions of the forewheel, that's 120 upon x. We know the number of revolutions by the rear wheel, that is 120 upon y. Now we need to form the equation on the basis of these number of revolutions. So let's do it. See, the condition given is forewheel of a carriage makes 6 revolutions more than the rear wheel. So forewheel, that is 120 upon x, makes is equal to 6 revolutions more than the rear wheel, that is 120 upon y plus 6, as simple as that. So forewheel of a carriage, that is 120 upon x, makes is equal to 6 revolutions more after leaving some space plus 6, then the rear wheel, that is 120 upon y. So 120 upon x is equal to 120 upon y plus 6. The equation is formed in terms of number of revolutions because 6 is the number of revolutions, right? Now rearrange it, all the variables on one side, constants on the other side. We get 120x minus 120 upon y is equal to 6. Now 120, 126, that can be further simplified by dividing throughout by 6, right? So let's divide throughout by 6 and we get 20 upon x minus 20 upon y is equal to 1. Let this be the first equation. Now similarly, in the same tabular form, let us now form the second equation. It's similar to what we have done. Let's do it. Now it is given the diameter of a four-wheel is increased by 1/4 of its present diameter. If diameter is increasing by 1/4, even the circumference will increase by 1/4, right? And if the circumference of the four-wheel is increasing by 1/4 of its present circumference, then what would be the new circumference of four-wheel? We have already studied. The new circumference will be x plus 1/4 of x. X is the original circumference of four-wheel, increases by 1/4, so the new will be x plus 1 upon 4x. We get 4x plus x upon 4, that's 5x upon 4. So the new circumference of four-wheel is 5x upon 4. Now let's find the new circumference of the rear wheel. Now let's see what is given. It is given that the diameter, that is the circumference of the rear wheel, is increased by 1/5 of its present circumference. So circumference of rear wheel, which is currently y, is increasing by 1/5 of its present circumference. So what will be the new circumference? It will be 1 y plus 1 upon 5 y, that is 5y plus y upon 5. So y plus 1 upon 5y, that is 5y plus y upon 5, the LCM, which is equal to 6y upon 5. So the circumference of rear wheel, the new circumference will be 6y upon 5, right? From the examination perspective, you are not supposed to show the calculations. You can directly write, since the circumference of four-wheel is increasing by 1/4 of its present circumference, the new circumference will be 5x upon 4. Even if you show the calculations, not a problem at all. How do we show it? The new circumference of four-wheel is equal to x plus 1 upon 4x, which is equal to 5x upon 4. And for rear wheel, it will be y plus 1 upon 5y, which is equal to 6y upon 5, right? Now it is given that they are covering the same distance. Now when we say same distance, the distance again is 120 meter each. Now it's time for us to find the number of revolutions. We got the circumference, the distance is given to us. So what remains is number of revolutions, and for that we'll be using the formula to find number of revolutions. Let's do that. Just take care of the calculations here. In four-wheel, the number of revolutions will be 120 upon 5x upon 4. So this 4 will go to the numerator. And similarly, rear wheel will be 120 upon 6y upon 5. 5 will go to the numerator. So what exactly we'll get? We get 120 upon 5x upon 4 is equal to 120, which is equal to 120 is equal to 4 goes to the numerator. As I said, we get 120 into 4 upon 5x. Let's do it. 524s, you get 24 into 4 upon x, which is equal to 96 upon x. That's the new number of revolutions of the four-wheel, 96 upon x. For rear wheel, it will be 120 into 5 upon 6y, which is equal to 620s, which is equal to 100 upon y. So the new number of revolutions is 100 upon y. So whatever equation that will be forming will be as per 96 upon x and 100 upon y. Now what is given? Four-wheel makes 4 revolutions more than the rear wheel. First condition, it was 6 revolutions more. This time it is 4 revolutions more. And what are the number of revolutions that we will be considering now? 96 upon x and 100 upon y. So let's do that. Four-wheel makes, four-wheel meaning, which one will you take? 96 upon x. Makes is equal to 4 revolutions more after leaving some space plus 4 than the rear wheel, that is 100 upon y. So 96 upon x minus 100 upon y is equal to 4. Now see, like in the previous condition, we had divided throughout by 6. Even here you can divide throughout by 4. But we advise don't do it in this. You can do it, you will get the answer. But in this sum we are advising don't do it. You will understand why once we go on to the calculation part of it, right? But I am telling you, if you want to divide throughout by 4 and simplify, it's perfect. You will get the answer. But by not doing it, you are actually saving 2 steps. You will understand why. So let this be the second equation. The 2 equations are there in front of you. Now let us solve it. To solve such an equation, there are variables in the denominator, so we need to go for substitution. X in the denominator, y in the denominator. So substituting 1 upon x is equal to a and 1 upon y is equal to b. You can use m and n as well. The choice is absolutely yours. Let's substitute in the first equation. What we get is 20a minus 20b is equal to 1. Let this be the third equation. Let's substitute in the second equation. You get 96a minus 100b is equal to 4. Let this be the fourth equation. Now we need to solve it by the method of equating the coefficients. Look at the coefficients of a. The coefficients are not the same. We can't eliminate a as of now. Look at the coefficients of b. The coefficients are not the same. We cannot eliminate b as of now. So we need to either make the coefficients of a same, or we need to make the coefficients of b same. Now look at the coefficients. Observe, I feel it is better to make the coefficients of b same just by multiplying the third equation by 5. So let's multiply equation 3 by 5 and make the coefficient of b same. Now just coming back to that point, that if you would have reduced it by dividing throughout by 4, you would have got 24 upon x minus 25 upon y is equal to 1, right? So here you would have had 24a minus 25b is equal to 1. This is what you would have had, right? Now to make the coefficients same, in that case, you will have to multiply the third equation by 5 and the fourth equation by 4, right? Because it would have been 20 and 25, you have to make both of them 100. So we are now saving that step of multiplying the fourth equation by 4 to make the coefficient same, and initially we saved that step of dividing throughout by 4. So basically we saved 2 steps just by not dividing throughout by 4. But even if you do it in the exam, it's perfectly fine. Just that you will have 2 extra steps, and ultimately what you will get as the fourth equation would be 96a minus 100b is equal to 4. The choice is absolutely yours, right? Currently, let's multiply the third equation by 5. We get 100a minus 100b is equal to 1 into 5 is 5. Let this be the fifth equation. So now we have the fourth and the fifth equation. We can see the coefficient of b is the same. Also the signs are same. So we are subtracting the 2 equations. When we subtract equation 5 from equation number 4, you need to write the fourth equation, then the fifth equation, and then don't forget to change the signs. Now we all are experts in this, right? So we can just quickly go through the solving part. Now let's do it. You get minus 4a is equal to minus 1. Minus minus becomes plus. You get a is equal to 1 upon 4. The moment you get the value of a, substitute a is equal to 1 upon 4 in the third equation. We get 20 into 1 upon 4 minus 20b is equal to 1. We get 5 minus 20b is equal to 1. Variables on one side, constants on the other side. We get 5 minus 1 is equal to 20b. We get 4 is equal to 20b. We get b is equal to 1 upon 5. We got a as 1 upon 4. We got b as 1 upon 5. Now it's time for us to resubstitute these values, right? Wherever there is a substitution, there has to be a resubstitution. So what we get is a is equal to 1 upon x, which is 1 upon 4, and b is equal to 1 upon y, which is equal to 1 upon 5. We take the reciprocal and we get x is equal to 4 and y is equal to 5. Because x is 4, y is 5, we come to a conclusion that the circumference of the fore wheel is 4 meters and rear wheel is 5 meters. As simple as that.